OCR Chemistry A 6.3.2 Combining Analytical Techniques. Using Chemistry Explained means participating by writing notes and completing the tasks with a pen on paper or on a tablet. Pause and replay the slides at the pace that suits you. Most importantly, when prompted, pause the lesson, thinking a problem through, taking your time, completing the task before continuing and correcting your work. It's rare that a single analytical technique will identify a full molecular structure. So to achieve a full determination of structure, interpretation of more than one type of analytical data is required. So the types that you have met at A level and will have to put together in a combination is percentage composition data, mass spectra, infrared spectra, carbon-13 NMR, and of course proton NMR. So the type of problem that you'll get at A level, you'll be given some data, for instance, some percentage by mass data, and you're asked to determine the structure of the organic molecule. In addition, you'll get spectral data such as mass spectrum, infrared, carbon-13 NMR, and proton NMR. So we're going to go through this data step by step to come to a full structural determination of the organic molecule that generated this data. So step number 1, determine the empirical formula from the percentage composition data. So here is the percentage composition data by mass: 62% carbon, 10.3% hydrogen, 27.6% oxygen by mass. Pause and calculate the empirical formula. Come back to check your answer when you're ready. Okay, well, I've divided through by the relative atomic mass to achieve 5.17, 10.3 to 1.725 as a ratio of moles, but I want a whole number ratio, so I'm going to divide through by 1.725. If I do that, I achieve 3 to 6 to 1, and that of course gives me an empirical formula of C3H6O. This is a simple whole number ratio of elements within the compound formula. So the second step is to interpret the mass spectrum. So use the molecular ion peak to determine the molecular formula, and use any other ion peak values to determine some structures present in the molecule. Pause, analyze the mass spectrum, calculate the molecular formula, and see if you can identify any structures within the molecule. Come back when you are ready to look at my interpretation. Okay, I'm about to reveal. So the molecular ion peak is at the value 58, which is the largest number on the mass to charge ratio on the x-axis. Please note I ignore the small peak at 59. That's due to the presence of isotopes such as carbon-13. So we ignore that. We take the molecular ion peak to be 58, which means that the relative molecular mass is 58. Now we know that the empirical formula is C3H6O from the previous slide, and that has an empirical formula mass of 58 itself. So I've chosen a simple example. In this case, the molecular mass, the relative molecular mass, is the same as the relative empirical formula mass. And therefore the molecular formula in this case is the same as the empirical formula, C3H6O. However, we can say more about this molecule because we've got a peak at 29, which corresponds to C2H5 plus, so a fragment of 2 carbons and 5 hydrogens, C2H5 plus, or a fragment of carbon, oxygen and hydrogen plus. So we can say that there is either C2H5 or CHO or both within the molecule C3H6O. We can also rule out CH3 groups because we don't have a peak at 15. That might be useful. So step 3, from the infrared spectrum, identify the bonds present, but also the bonds that are absent, that are not present. Pause, with reference to the data sheet, identify the bonds present and see if you can relevantly comment on the bonds that are not present. Come back when you're ready to hear my ideas. Okay, so if we look at the absorptions that are present, we can see a distinctive 1630 to 1820, which is the carbon double bond oxygen. So this molecule contains the carbon double bond oxygen. And we've also got carbon and hydrogens in alkyl groups indicated by strong absorption in 2850 to 3100. We can also comment on the bonds that are absent, bearing in mind that the empirical formula or the molecular formula has got oxygen in it. It's relevant to say that there isn't an absorption corresponding to the oxygen-hydrogen bond. So we can rule the oxygen-hydrogen bond out, and we can also rule out the carbon single bond oxygen. Moving on now to carbon-13 spectra. Pause. What information can you get, what relevant information can you get from the 3 peaks that appear in the carbon-13 spectra? Come back when you are ready to compare with my answers. Okay, so the first and most obvious thing, of course, is that the 3 peaks in the carbon-13 spectra indicates there are 3 different carbon environments within the molecule. And we can also identify them based on their shift values. So shift value 220 to 160 indicates a carbon double bond oxygen. That of course agrees with the infrared spectra that we looked at on the previous slide. But we've also got carbons within a carbon-carbon environment. And we've got 2 of them, but they don't have identical shift values, which implies that one of the carbons is closer to an oxygen, an electronegative element, than the other. Moving on to the proton NMR, pause the video, think carefully about your interpretation of this spectrum. Come back when you're ready. Okay, so the first thing to say, of course, is that there are 3 signals, so therefore there are 3 proton environments within the molecule. Our right-hand side signal, there are 3 protons in this proton environment, and the subpeaks form a triplet. So that tells us that the neighboring carbons carry 2 protons. So we've got 3 hydrogens on a carbon, and there are 2 protons on neighboring carbons. If we move now to the central signal, there are 2 protons within this environment. If you look carefully, this is a quintet, there are 5 sub-peaks, 1, 2, 3, 4, 5. So that tells us that the numbers of protons on neighboring carbons is 4. There are 4 protons on neighbor carbons. And if we move to the left, we see this is a triplet. There's 1 proton in this proton environment. So that means that there's 2 protons on neighbor carbons, neighboring carbons. So within the molecule, we have a carbon with 3 hydrogens and 2 protons on neighboring carbons. We've got a carbon with 2 protons but with 4 protons on neighboring carbons, and then we have a carbon with 1 proton, 1 hydrogen, but there are 2 protons on the neighboring carbons. So what we need to do now is to pull all this information together to make a firm conclusion as to the structure of the unknown organic molecule. So we've got percentage composition data and mass spectra. If you recall, we put that all together to give us a molecular formula of C3H6O, which contained either C2H5 or CHO, or both. From the infrared spectrum, we got the molecule containing the carbon double bond oxygen and carbon hydrogen, but not oxygen hydrogen nor carbon single bond oxygen. From the carbon-13 NMR, we got there are 3 carbon environments, and again we identified the carbon double bond oxygen as one environment and the carbon-carbon environment, with 1 carbon being closer to the oxygen than another. At this point, it's absolutely possible to propose a structure for the molecule. Pause, propose a structure, come back to discuss it with me when you're ready. Okay, so to reveal what I think the molecule is, I have propanal, C3H6, contains the C2H5. I'm going to draw a few lines here. C2H5 is there, and CHO is there. Contains the carbon-oxygen double bond. Okay, I'm making a bit of a mess, but you get the picture. 3 different carbon environments. 1, 2, and 3. So pretty clear that that is propanal from the data so far. But if we bring in the proton NMR, then again we've got 3 proton environments. Definitely the case. We've got 3 protons next to a carbon, so 3 protons next to a carbon with 2 protons, so that ticks that box. 2 protons adjacent to with carbons carrying 4 protons. So if we look at here, we've got 1 here and 3 here, so we've got 4 protons on neighboring carbons, and then finally we've got 1 proton adjacent to a carbon which carries 2 protons. So this carbon has 1 proton next to a carbon that carries 2 protons, definitely confirming propanal. It's a good idea at this point to do some practice questions. If you have the OCR endorsed textbook, I suggest page 533. There's one summary question very similar to the problem that I've just worked through, so I'm hoping that will be straightforward. The answers are on page 592, but if you have other textbooks, there will be suitable questions in the appropriate chapters.